Good day, students. Welcome to part one of the review session. In this clip, we're going to be focusing on how to solve quadratic equations. So let's go ahead and take a look at question number one. It says, what are the solutions to the equation x squared minus 20x equals negative 100? So what I'm going to do first is place this quadratic equation in standard form. Basically, make it equal to 0 with the powers in descending order. Okay? So to accomplish that, I'll need to move this 100 to the left. So I need to add 100 to both sides. And that yields x squared minus 20x plus 100 equals 0. All right. There are two ways we're going to solve this problem. We're going to do it by factoring and then use it. I'm going to factor it in two different ways. The x game and then using the perfect square trinomial factoring trick. Okay. So method one, we're going to use the x game. Okay. Or you can call it the AC method. All right, so let's go ahead and do this. This is a longer method I'll do first, and then I'll show you a quicker way. So we have x squared minus 20x plus 100 equals 0. So we're going to make our little x on the right. AC goes on top, B goes on the bottom. So let's see. AC, we have the coefficient of the x squared is 1. So we have A, B, C. So AC is 100 and B is negative 20. So what two numbers multiply to give you 100 and add to give you negative 20? They can you do negative 10 and negative 10, right? So let's plug that in here. We'll have x squared minus 10x plus 100. All I just did is replace negative 20 with these two numbers. Now I'm going to break it down the center, and then we're going to factor by grouping, okay? All right, so let's break down our respective factors. On the first two to the left, we're going to break down x squared is going to be x times x, minus 10 is 5 times 2 times x, and then on this side, negative 5 times 2 times x, plus 100 is 2 times 5 times 2 times 5. All right, from the first two, I can take out x. All right, so let's factor that out. Factor out the x, we're left with x minus 10. And then from the next two, I'll take out 5, 2, 5, 2, and a negative, so we'll take out negative 10. And then we're left with x minus 10. If you factor out a negative, this plus changes to a negative, okay? Now, these two terms on the outside, we'll bring them together. And then we can factor out the x minus 10, put that together, factor it out, x minus 10, and we're left with those two terms on the outside, which is x minus 10, and that's the factored form equals 0, okay? All right, now, to solve this, we set both of them to 0, so x minus 10 equals 0, and x minus 10 equals 0. So they both the same thing, so if we solve one, that will be sufficient. All right, so just add 10 to both sides, and then we have x equals 10 as our answer. All right? Okay. Now, let's try using another method. Method 2, we're going to use the perfect square trinomial factorization. Okay? Method 2. Method 2 is I'm going to call it PSC, perfect square trinomial factorization. All right. Now I'm going to start right off from the standard form of the quadratic equation we had, which is x squared minus 20x plus 100, x squared minus 20x plus 100. Now this method works only for perfect square trinomials. How do you know if this is a perfect square trinomial? The question is, if I root the first term, if I double the square root of the first term and the last term, do I get the middle term? 20x, do I? If I do double the square root of this and that, do I get the middle term is the question. So this is 2x times the square root of 10 is 10. And if you times these two together, you have 20x equals 20x. So if this check works, if double the root of the first and the last equals the middle, then it's a perfect square trinomial. So you see that it works here. So if you want to factor this using the perfect square trinomial factorization, all you do is you take the square root of the first term and the last term, and then you bring down the middle sign. Okay? So there you have x minus 10 quantity square equals 0. Okay? And then to finish this up, you just simply take the square root of both sides. You root the left and the right. And then you have x minus 10 equals plus or minus 0. 0 has no orientation, right? So you just have x minus 10 equals 0. Add 10 to both sides. And then you have x equals 10. All right? So there goes your final answer. All right. Now let's go ahead and take a look at the next problem. Well, let's circle our answer for number 1. Our answer for number 1 is C. We got 10 in both methods. You can see that method 2 is much quicker. All right, next question, number 2. It says, what are the solutions to the equation negative 4b squared minus 4b minus 4 equals 0? You can see the radicals here clearly indicate, or is a hint that this is going to be a prime uh, quadratic. It cannot be factored. So we need to resort to a formula or an approach that guarantees that we can find the answers. So factorization won't work, so we can either use completing the square or the quadratic formula. The quadratic formula is much easier to use, so let's go ahead and use that, all right? So x equals negative b plus or minus the square root of b squared minus 4ac, that whole third divided by 2a, okay? All right, let's go ahead and solve that. So we're going to have, in this problem, let's rewrite it, negative 4b squared minus 4b minus 4 is already in standard form, so we can extract a, b, c without any problems. Okay, so a is negative 4, b is negative 4, and then c is negative 4 also. All right, so what I'm going to do is plug all of this into my quadratic formula. Let's see what we get. So we have x equals minus negative 4 plus or minus the square root of negative 4 squared minus 4 times negative 4 times negative 4. That's 4ac. And that whole thing divided by 2a, which is 2 times negative 4. Okay? Divided by 2 times negative 4. All right, let's go ahead and work this out. All right, so using the order of operations, we're going to simplify this entire expression right here. So negative times negative is positive. So we have 4 plus or minus the square root of negative 4 squared is 16. Minus times minus is a plus times a minus is a minus. 4 times 4 is 16. 16 times 4 is 64. Okay. Now let's divide that by negative. 2 times negative 4 is negative 8. Alright, let's go ahead and simplify the radicand. We're going to have this equals 4 plus or minus the square root. 16 minus 64 is 48. It's going to be negative 48 over negative 8. Alright, let's go ahead and simplify negative 48. So, square root of negative 48. The square root comes out of the radicand as an I. So, let's break this down. Take out 2 into 48, 24. 2 goes into 24, 12. 2 goes into 12, 6. 2 goes into 6, 30. Okay? So, let's see. 16 times 3, yes, perfect. All right, now what does this mean? Any factor that repeats itself, we can extract out. So these two 2's, 2 times 2, if you read that, that comes out as a 2. And then these two 2's, 2 times 2, if you read those 2 times 2, it comes out as a 2. So this 3 stays behind, all right, stays behind. So the square root of negative 48 is simply this 2, you multiply them by each other, so you get 4, and then the I, 4i, and you're left with the 3 as a radicand, 4i root 3, okay? So that becomes 4 plus or minus 4i root 3 over 8, over negative 8. Okay, so now let's go ahead and split it up so we can simplify. So we're going to have negative 4 over 8. See this negative downstairs? It came out because positive over negative is negative. Plus or minus, the opposite of plus or minus is minus or plus, which is the same thing as plus or minus. 4i over 3 divided by 8. Okay, you want to split it up first before you reduce so you don't make mistakes. Okay, let's reduce this. I'll divide this by 4 top and bottom. The first uh, portion of this expression will be reduced into negative 1 over 2 plus or minus. We'll do the same thing here, so I can divide by 4 top and bottom. I'll have uh, root 3 over 2. We put an I after the number. Okay, so it's negative 1 half plus or minus root 3 over 2. That's our final result for this question. Okay, so the correct answer is option A, I believe. Yes, option A. So you gotta be careful with the sign in that denominator. Okay, so the answer is option A. Good day, students. Welcome to part 2 of the review series. We're going to be focusing on right triangle trig and the Pythagorean theorem in this set of problems. Okay. All right. Let's go ahead and take a look at question number 4. It says a new pipeline is being constructed uh, to route oil flow around the exterior of a national wildlife reserve. The plan showing the old pipeline and the new route is shown below. About how many extra miles will the oil flow once the new route is established? So um, this is the reserve right here, the preserve, sorry. This is the preserve right here. We have a rerouting taking place. So this is a new route, and this is the old route. The new route is a little bit longer. So the question is, after this new route is completed, how many extra miles uh, will the oil flow? Okay. So in order to determine what how much longer the new pipeline is, we need to figure out the length of the old pipeline. Okay. So we know that the new pipeline is 28 plus 21 miles long. You go starting from here, 21 plus 28. So the oil is going to flow 49 miles. For the old pipeline, we don't know what it is, but since this is a right triangle, we can use Pythagorean theorem to simply figure out what the length of the old pipeline is, okay? So how about we just make a sketch of the triangle, and then we're going to put in the measures and figure out the length of the old pipeline, okay? So there goes a right triangle right there. This is a right triangle with a 90-degree angle. So opposite the 90-degree angle is the hypotenuse. I'm going to call this C, and then call this A, which is 28, and then let's call this B. Now, whenever you're using Pythagorean theorem, the legs do not matter how you label. It doesn't matter how you label the legs, um, but the hypotenuse is always C. So you gotta keep that in mind. All right. So C is actually the length of the whole pipeline. So to figure that out, let's write down the Pythagorean theorem. C squared equals A squared plus B squared. So we have C squared equals 28 squared plus 21 squared. So we have C squared equals, let's plug that into our calculators and see what we get. So C, 28 square plus 21 square is 1225. Okay, so C square is 1225. So to get C, all we'll just simply do is we're going to take the square root of both sides. So take the square root of that and the square root of that. And we have C equals, well, let's see, what is the square root of 1225? So square root, I'm going to insert the answer using second function negative 35. Okay, so C is 35. All right, so the old pipeline is 35 miles long. All right, so let's be careful with what the question asks us. It said, how many extra miles will the oil flow in the new one? So the extra miles is simply the difference. Okay, so extra mile traveled, extra miles traveled is basically the new minus the old, right? So the new is, what was the new again? 49. 49 minus the old, which is 35. So 49 minus 35 is 14 miles. So our correct answer is option A. Okay. All right, let's move on to the next question. Question 5. It says, what is the approximate height in feet of the tree in the figure below? So we have a right triangle situation here also. But we're given an angle, so let's complete the right triangle. We can use right triangle trigonometry. All right. So what am I talking about? I am talking about SOHCAHTOA. Okay, that's right triangle trig. All right. So what do we have here? We want to focus on what we need and what we know, and then that will help us determine the right ratio to use, if it's sine, cosine, or tangent. Okay. So let's see. We're looking for the height of the tree. Let's call that x, and then we know what this is. So the angle that we're given, this is the angle that we're given right here, 54 degrees. If this is a reference angle, that means the side opposite the angle is going to be called your opposite, okay, for O. And this side opposite the 90 degrees is your hypotenuse. Now this is the adjacent. In this problem, we don't know the adjacent, we don't need it, so we just scrap it. Please no row here. So we just want to focus on opposite, what we need, and the hypotenuse, which we know. So what trig ratio has O and H in it? It's obviously sine, right? So sine is a trig ratio that we're going to use to solve this problem. All right, so sine 54 equals opposite over hypotenuse. All right, so to isolate x, we multiply both sides by 88. So the height of the tree x is going to be 88 sine 54. So let's plug that into our calculators and see what we get. 88 sine 54, and the answer is 71.2 to 2 decimal places. So it's approximately 71.2 feet. So the correct answer is option A. Okay. All right. Let's go ahead and move on to question number 6. It says the right triangle's hypotenuse has length 20. If one leg has length 10, what is the length of the other leg? Okay. So remember the legs are A and B, and the hypotenuse is always C. Okay, so we know that A, we can call A 10, and we can call B question mark as indicating that we do not know, and C equals 20. All right, we can use the Pythagorean theorem here because we deal with a right triangle. Okay, so the right triangle relationship between the lengths are the hypotenuse square equals the sum of the squares of the legs, A squared plus B squared. Okay, let's populate this equation with what we know and what we need. So we have 20 squared equals 10 squared plus b squared. 20 squared is 400, and 10 squared is 100 plus b squared. Okay, now we'll subtract 100 from both sides. Subtract 100, subtract 100. Using the reflexive property of equality, we can rewrite this as b squared equals 400 minus 100 is 300. Okay, now to get b by itself, you just simply take the square root of both sides, and then we'll have b equals the square root of 300. So the answer for number 6 is option A. All right, let's move on to the next question. Question 7. It says to find the height of a tower, a surveyor positions a small transit that is 2 meters tall at a spot 85 meters from the base of a tower. She measures the angle of elevation to the top of the tower to be 29 degrees. What is the height of the tower to the nearest meter? Okay, so let's go ahead and make a sketch of the situation. So we have a transit positioned 85 meters from the base of a tower. So let's say this is a tower right here. So we have the transit is 85 meters away from the base of the tower. 85. The transit is not on the ground. The transit has a height of 2 meters. Okay, so the height of the transit from the ground is 2 meters. All right, so this is the ground right here. All right, so we can even put the legs of the transit. Well, let me not get you confused. So let's just do it like this. So there goes the transit right there, and then we have the lady standing right here, and she's looking into the transit. Obviously, she wants to have it at eyesight, so that's why it has a 2 meters off the ground. Okay, so the height of the transit is 2 meters. This is 2, so that means this is 2 also. And the angle of elevation to the top of the tower of the transit is 29 degrees. So this is 29 degrees elevation from the line of sight or the horizontal. So let's label that. This is 29 degrees. So the question said, what is the height of the tower? So the height of the tower, we're going to find this length right here, and then we're going to add it to the height of the transit, and that will give us the height of the tower. Okay, so we want to find this, that length, whatever that is, plus the height of the transit, that will give us the height of the tower. Okay, so let's call this x. All right, so we have a right triangle trig scenario here because we have two sides and an angle being involved. So what trig ratio are we going to use in SOHCAHTOA? Is it sine, cosine, or tangent? All right, let's look at what we need and what we... All right, so this is the reference angle, so that means the side opposite it, this side right here, is going to be the opposite, which is the side we need. And this side right here is the adjacent, which is the side we know. The hypotenuse opposite the 90 degrees, we don't need it, we don't know it, so forget about it, all right? So which trig ratio has O and A? Which trig ratio relates the opposite and the adjacent? This is a tangent function, right? So we're going to be using tan to solve the situation, okay? So we're going to have tan of the angle, 29, equals opposite, which is x over adjacent. Remember, x is not the height of the tower. The height of the tower is, let me show it to you, is x plus 2. It's that x plus the height of the transit. Okay, so we have to be really careful about that. So the height of the tower is going to be x plus 2. All right, so let's go ahead and find out what x is, and then we'll add 2 to figure out the final answer. So to get x by itself, we multiply both sides by 85, and then we're going to plug that into our calculator. All right, so we're going to do 85 tan 32, tan 29. That will be the measure of x. So 85 tan 29. And then we get 47. It's basically 47 meters to the nearest integer. Okay? So let's go ahead and write that down. X is 47 meters. So is that a correct answer? Is the answer option D? Absolutely not. Remember, we need to add the height of the transit, okay, to x to get the height of the tower. Okay, so the height of the tower, is basically 47 plus the height of the transit, which is 2. So our final result will be 49. So the answer to this is option A. All right, so there you have it. All right, moving along to the next question, question 8. It says the picture frame below is a rectangle with dimensions 16 inches by 7 inches. What is the length of the diagonal of the picture frame? Okay, so let's see. If we draw a diagonal, what do we have? We draw a diagonal for the rectangular picture frame in this orientation. You notice we have a right triangle, so we can basically use the Pythagorean theorem here because we're given two sides and we want to find the third side, okay? So what we're going to do, I'm going to extract this triangle, and then we're going to use Pythagorean theorem to figure out the side of the length of the diagonal, okay? That length right there is the diagonal. So let's go ahead and extract it out. So let's see. We have some measures that we know. The one on the bottom is 16, the horizontal length, and then the vertical length is 7 inches. And this is diagonal right here. Let's call it C. Okay? Why am I calling it C? Well, it happens to be the side that's opposite the hypotenuse. It doesn't matter what you call it though. So it's opposite the 90-degree angle. So this is the hypotenuse, and the hypotenuse using the naming system of the Pythagorean theorem is always C. Okay, so I'm going to call this A and B. Remember the legs, the labeling of the legs are interchangeable. I can call this A and B and I'll still be correct, okay? So C is the diagonal. So we're going to use the Pythagorean theorem, C squared equals A squared plus B squared. And then we're going to have C squared equals 7 squared plus 16 squared. All right, let's plug that into our calculator and see what we get. Okay, so we have 7 squared plus 16 squared, which is 305. So C squared is 305. Let's write that down. C squared is 305. So C is going to be the square root of both sides. So let's root both sides. So C is root 305. Okay, so C equals root 305, and that's the length of the diagonal. And the answer is option C. All right, moving along to the next question. Question 9. It says, triangle JKL is shown below. Which equation should be used to find the length of JK? Okay, so let's see. We're looking for the length of JK, so how about we call that X? This is the segment that we're looking for. All right, so now let's label. This is a right triangle. We have an angle, so we can use right triangle trig here. So katawa. So let's see which one can we use. So let's see. We're going to label what we need and what we know, and then that should help us determine the right ratio to use, the right function to use. Since this is the angle under consideration, the side opposite that angle is going to be your opposite. Okay? And then this side right here is opposite the 90-degree angle. The longest side of the triangle is your hypotenuse. So which trig ratio relates O and H? It's sine, right? So we're going to go sine of the angle, sine 33, equals opposite of a hypotenuse. All right? So you get x by itself, we'll multiply both sides by 34, 34, 34, and then we have x equals 34 sine 33. Let's plug that into our calculators. 34 sine 33. Final answer is, well, actually, we don't actually have to solve it. We're just supposed to just set it up, right? I'm doing x right here. So let's see, if we just want to focus on the setup, um, there goes the setup right there. Sine 33 equals x over 34. X is jk, right? So let's go ahead and make use of that. Erase the other stuff. They're not necessary. All right, so take that out, take that out. So we have, the answer is going to be sine 33 equals x is jk over 34. Okay? Sine 30 equals jk over 34. Final answer is option D. All right? Okay. Now the last question, question 10, it says, what is the approximate value of x in the triangle show? So this is a right triangle trig problem again, because we have two sides and an angle. So let's see. This is the angle under consideration. So the question is, in SOHCAHTOA, to find that angular measure, are we going to be using sine, cosine, or tangent? So this is the angle, so that means the side opposite the angle, that's going to be the opposite. And the other side we know is opposite the 90 degrees, which automatically makes it the hypotenuse. All right, so which trig ratio relates O and H, opposite and hypotenuse? It's sine, right? So we have sine x equals the opposite, which is 13 over the hypotenuse, which is 15. To isolate x, we got to take the inverse sine of both sides. So the inverse sine of sine x equals the inverse sine of 13 over 15. Okay? All right, so this cancels out. So we have x equals the inverse sine of 13 over 15. Let's plug that into a calculator and see what we get. Second function sine gives us the inverse sine of 13 divided by 15. Answer is 60.073 to the nearest decimal place. The 10th place is 60.1. Okay, so x is going to be 60.1 degrees. 60.1 degrees. And that is option D. All right, so that's that. Good day, students. Welcome to part 3 of the review session. All right, let's go ahead and take a look at number 10. It says, Leola drives 23 kilometers uphill, that is at a grade of 11 degrees. What horizontal distance to the nearest tenth of a kilometer has she covered? All right, so let's go ahead and make a sketch of the situation. So she goes uphill 23 kilometers, and it's at an angle of 11 degrees. So this is 11 degrees right here. This is 23 kilometers. So it says, what's the horizontal distance she covered? So we call this x. Now, since this is the angle under consideration, this is your 90-degree angle. This side up here will be your hypotenuse. and this would be your adjacent. Okay, so what trig ratio relates to the hypotenuse and the adjacent in SOHCAHTOA? In SOHCAHTOA, the trig ratio that relates to the two of them is cosine ka. Okay, so we have cosine 11 equals the adjacent over the hypotenuse. All right, to get x by itself, multiply both sides by 23. And then our answer will be x equals 23 cosine 11. Let's plug that into our calculator and see what we get. Plug that, 23 cosine 11. And the answer is 22.5. Or 22.6 to the nearest tenth. All right, so 22.6. So x is approximately 22.6 kilometers. All right, and our answer is option C. All right, let's take a look at question 11. It says convert 1 over 10 pi to degrees. All right, so we're converting 1 over 10 pi to degrees. So in this case, we can write 1 over 10 as pi over 10, and then multiplied by 180 over pi. So the pi's divide out, the zeros divide out. If you multiply across, you have 18 degrees, okay? So the radian measure of 1 over 10 pi in degrees, the degree measure of 1 over 10 pi radians is 18, okay? All right, let's take a look at question number 12. Convert 9 degrees to radians. So 9 degrees, to convert this to radian, I'm going to multiply it by the conversion factor with the degree on the bottom, namely pi over 180 degrees. All right, so the pi's cancel out. 9 goes here 1, 9 goes here 20 times. So our answer is pi over 20. You can also write this as 1 over 20 pi. Final answer is option C. All right, let's take a look at question 13. It says, which of the following is y equals sine x? Just a real quick review. Remember your sine is like an S starting from the origin. See, sine is like an S. Let's go ahead and sketch that. And cosine is like a cup starting from the origin, so it looks something like this. Okay, so we were looking at sine. Which one starts from the origin and goes make an S in the upward direction is option C. All right, so that goes our answer. All right, number 14. What's the value of cosine? To do this, we're going to consult our table of common trig angles. So let's bring that up. So we're looking for cosine pi. So we have cosine here and pi. They meet at -1. All right. So cosine pi is -1. All right. So let's indicate that. Let's see. Cosine pi from the chart is -1. Final answer is B. All right, let's take a look at number 15. It says find the exact value of 12 sine 135. So what we'll do is we'll use our table of common trig angles to figure out what the sine component is and then multiply by 12. So we have 12 times. Now what is sine 135? Take up our units, our table of common trig angles. So sine 135 is root 2 over 2. Okay, so that's what we're going to use. Root 2 over 2. So how do we reduce this? We just write this as 12 over 1, divide by 2. 2 goes here 1, 2 goes here 2. And then when we multiply it across, we're going to have, actually 2 goes here 6 times, not 2 times. 2 divided by, 12 divided by 2 is 6. All right, and then when we multiply across, we'll have 6 root 2. So our final answer is option B. All right, let's move on to the next question. Question 16 says find the exact value of 2 cosine -3 pi over 4. So we use our table of common trig angles to find what cosine -3 pi over 4 is, and then we can double our result. All right, so let's see. The negative angular measures on the bottom. We're looking for, let's see what we're looking for again, cosine -3 pi over 4. So -3 pi over 4 is down here. Trace it up to cosine. Cosine is the second row. We see that is negative root 2 over 2. That's the answer, negative root 2 over 2. All right, so we're going to have, this is going to become 2 times negative root 2 over 2. And then 2 goes here 1, 2 goes here 1. Final answer is negative root 2. Okay, and it's option C. All right, let's move on to question 17. It says draw angle 133 in standard position and find its reference angle. All right, so to draw that, this is just a sketch. We're more concerned with what quadrant it ends in. So we have a positive angular measure here, so that means we're going to be rotating counterclockwise. All right, remember clockwise is negative. So starting from 0, quarter of a circle is 90 degrees. Too small, keep going. Another quarter is 180 by adding 90. That's too big. That means 133 should reside somewhere between these two in quadrant number 2. All right, so this is the angle swept by 133. This angle right here. The reference angle is the measure from the terminal side to the closest x. Okay, the closest x to the terminal side right here is this angle right here, so that goes the reference angle theta r. All right, so your reference angle, theta reference, is simply going to be, this is 133, right? The angle of separation between these two, which is 180 minus 133 degrees. Final answer is, see, 47 degrees. 47 degrees. That's your reference angle. All right, so let's see which one matches. This is a good one, so yeah, actually, our answer is option A. All right. All right, let's move on to question 18. It says, which is the simplified form of this rational expression right here? So you have negative 5x plus 5x squared over negative 30x plus 30. So let's take out the numerator first and factor it. Numerator is negative 5x plus 5x squared. So let's break that down. We're going to have negative 5 times x plus 5 times x times x. We can take out 5x. So we're left with we have 5x on the outside, negative 1 plus x. Okay? All right. And then the denominator, we're going to factor negative 30x plus 30. So 30 breaks down into 2 times 3 times 5 times x, and then 30 breaks down into 2 times 3 times 5. All right, so we can clearly see here, we can factor out 2 times 3 times 5, 2, 3, 5, 2, 3, 5. So we have 2 times 3, 6, 6, I'm sorry, it's 30. So we have negative, factoring out positive 30 actually. So when we factor out positive 30, all right, so let's go ahead and do this one again. So we have the numerator. The numerator is negative 5x plus 5x squared. Let's break that down. That's basically negative 5 times x plus 5 times x times x. So I can take out a 5 and also an x. Let me factor out the minus. If I factor out a minus, it's going to be minus 5x and then 1, and then this sign changes to a negative minus x. Okay? All right, let's do the denominator. For the denominator, we have negative 30x plus 30. So I can break this down to negative 2 times 3 times 5 times x plus 2 times 3 times 5. So we take out a 2, 3, 5, 2, 3, 5, and then a negative. That's negative 30 times x minus 1. Okay? Times x minus 1. All right, so we can divide these two. We have negative 5x over 1 minus x divided by negative 30 times x minus 1. We can switch the order of the denominator and change the sign, so it becomes negative 5x times 1 minus x over positive 30 times 1 minus x. Okay? These two divide out, so we have negative 5x over 30